Hello, good morning dear students. So this video is based on chapter number 17, circles. Okay, so basically we know the shape of a circle, and exactly at the center, this point O is called the center of the circle. And if I draw a line from center to its circumference, let's say EO, this is called the radius. So center, and this is the radius, and the perimeter or the boundary of the circle is known as circumference of circle. Okay, so three things out here: center, radius, circumference. Okay, come back to the second diagram out here. Again, a circle is there, center, and I hope you can see a straight line passing to the center. Now this straight line which passes through the center of the circle is called the diameter. Okay, and just below the diameter I've drawn AB, a straight line, not the straight line, and this straight line out here, it's not just a straight line. This straight line is called the chord of the circle. Okay, in fact a diameter is also a chord. It is the longest chord, but this is a comparable shorter chord in compared to the diameter. So this AB is called the chord, and this which passes through the center is called the diameter. So center, radius, circumference, diameter, and chord. So now we'll learn more about chords and some theorems. Okay, so alright. So I hope people are familiar with radius, circumference, diameter, center, chord. Okay, so now out here you can say as the heading chord properties. So properties of chord. Let's see now. So here in the figure you can see a circle and center, chord, and there we can see a straight line OQ, isn't it or not? Okay, let's read the theorem. So the statement of the theorem states that a straight line drawn from the center of a circle to bisect a chord which is not a diameter is right angled to the chord. Now this straight line is right angled to the chord, means this straight line which is dividing this chord AB, because it's bisecting the chord, this straight line OQ will be 90 degrees with the chord. So this is the statement of the theorem. In any circle you draw a chord and then you draw a straight line from the center to bisect that chord. This straight line and the chord will be perpendicular to each other, so 90 degrees. Okay, theorem number 23. Now theorem number 23 is just the converse of theorem number 22. Let's read the statement, then we'll understand. Okay, the perpendicular to a chord from the center of the circle. You can see out here, this is a circle, center, the perpendicular to a chord. So this is the chord, and we are drawing a perpendicular to this chord from the center of the circle, bisects the chord. So bisects means this OQ divides AB equally. Alright, so just the opposite. Out here circle was given to us, a chord was given to us, isn't it or not? Circle, chord, and then from center I'm drawing a straight line which is bisecting. In this case this angle will be 90 degrees. Just the opposite now. Come back out here, a circle is there, a chord is there. Now if this is 90 degrees, then this bisects this chord. So theorem number 22 and theorem number 23. Now we'll see some applications of 22 and 23 in exercise 17E. So copy this in your copies and let's get back to 17E. Okay, now so exercise 17E is application of 22 and 23. So exercise 17A, question number 1. Let's read the question. A chord of length 6 cm is drawn in a circle of radius 5 cm. So a chord of length 6 cm is drawn in a circle of radius 5 cm. So two things are given to us. The length of the chord is given to us, chord AB 6 cm, and the radius of the circle is 5 cm. So let's draw the figure of a circle. Draw a circle, right? Draw a circle and then draw the chord. See, this chord is 6 cm, AB 6 cm, and then the radius is 5 cm. So circle, center, chord. From here to here it is 5 cm because it's the radius. From here to here is 6 cm because it's the chord. We are asked to calculate its distance from the center of the circle. Calculate the distance between the chord and the center. We need to calculate this OQ. We need to find OQ. So what we'll do is we'll do construction out here. Construction, drop a perpendicular OQ on AB. So this is already given to us, and this was given to us. Now from here, I'm drawing a perpendicular on AB. So perpendicular on AB. So using theorem number 23, what we know is that as this is perpendicular, so this bisects AB equally. So AB is been bisected. AB was 6. Now this becomes 3, and this becomes 3. Okay. So all in all, if I draw a perpendicular and this is 3, 3, then I can see there is a right angle triangle. OQA becomes a right angle triangle. So therefore, in triangle OQA, in right angle triangle OQA, by Pythagoras theorem, we know that this is my hypotenuse, this is perpendicular, this is my base. So therefore, using Pythagoras theorem, in this triangle, OQA, so this is 5 square is equals to 3 square plus O cube square. You solve it and you get the value for OQ as 4. So hence, what is the distance between the center and the chord? Because OQ, isn't it? The distance between the center and the chord is how much? 4 centimeter. So pause the video to note it down. Alright, now next we move to question number 2. So please read the question from your book. It is in your page number 210. Okay, so please read the question for yourself. A chord of length 8 cm is drawn at a distance of 3 cm from the center of the circle. Calculate the radius. So just the opposite is given to us. Draw a circle and then a chord. Okay, draw a circle and then mark the center O and draw the chord. Right? I hope you're clear till here. Great. Now, so as the length of the chord is 8 cm, and the distance between the center and the chord is 3 centimeter. So the length of the chord 8 centimeter, distance between the center and the chord is 3 centimeter. So this is 3, and I know that once I drop a perpendicular, this and this are equal because the perpendicular bisects the chord equally. So hence this becomes 3 and this becomes 4, and I hope again you can see clearly that here we get a right angle triangle OQA again. So in this right angle triangle, from Pythagoras theorem, we know that OA square equals to 4 square plus 3 square. 4 square means 16, 3 square means 9, 16 plus 9, 25. So AO square equals to 25. So AO is root 25. AO becomes 5. So hence AO is nothing but the radius. So hence, what is the value for the radius of circle? 5 centimeter. Pause the video to note down again. Alright, now we move to question number 4. Right, a chord of length 24 centimeter is at a distance of 5 centimeter of the circle. So let's divide this question into 2 parts. So I'm just doing till the first part for now. Okay, a chord of length 24 centimeter is at a distance of 5 centimeter from the center. Okay, you draw a circle, locate your center, and this is your chord AB. Okay, remember the length of the chord AB out here is 24. So I'm dividing it 12 and 12. Right, and the distance between the chord of length 24 centimeter is at a distance of 5 centimeter from the center. So the distance between the center and the chord is how much? 5 centimeter. So this is your 12, this is your 12. No doubt this is your 90 degree from theorem number 22, isn't it not? So hence this is 12, this is 12. The perpendicular is bisecting the chord. Okay, this is 12, 12, and this is 5. So again, I hope you can see there is a right angle triangle OQA. So right angle triangle OQA. So find the value for AO by Pythagoras theorem, and AO out here will be how much? 13. Remember, this AO is the radius of the circle. Radius of the circle. So till here, pause the video to note down and understand. Okay, I hope you're clear. Great. So now we move ahead. The second part of the question is asking you find the length of the chord which is at a distance of 12. Find the length of the chord of the same circle. Please be clear, of the same circle. Find the length of the chord of the same circle, but which is at a distance of 12 centimeter from the center of the circle. See, from here to here it was 5. Distance between the chord and the center is 5. Now I need to find the length of this chord which is below AB, length of this chord, are you understanding, which is at a distance of 12 centimeter. So from here to here it is 5, so 12 will be below this. So hence what we do is use a pencil and ruler and drop this chord down there till here. So I need to find this is my perpendicular, and I need to find the length of LM. Okay, and yes, this I'm keeping it as P. Okay, I hope you're clear. And then again, what I do from here is please join O and L like this. Okay, join O L. This becomes your 90 degree, and now we can proceed. Yes, so I hope now you can see another right angle triangle, OLP, or you can also take it as OPL, isn't it not? Right? Okay, now from here to here it is 12. Please be clear that from here to here it is 12, because I am asked to find the length of this chord. I am asked to find the length of this chord LM, which is at a distance of 12 centimeter from the center. Which is at a distance of 12 centimeter from the center. Are you understanding? And please be clear with that. OL and OA. See, OA is also the radius. OL is also the radius. So no doubt, if OA is equal to 13, then OL will also be is equals to 13 centimeter. So therefore, in triangle OPL, if you even make the figure for this, you will be getting something like this, huh? OPL, this is 90 degree, OL 13, this is 12. So can you find the length of LP? Can you find the length of LP? The moment you find the length of LP, multiply into 2, you'll get the value for LM, which is the length of the chord, which is at a distance of 12 centimeter from the center. The whole calculation is out here. So I'm just going to give a quick calculation out here. In this triangle, use your Pythagoras theorem and find the length of LP. Find the length of LP is 5. This is 5. So once this is 5, so 5 plus 5 becomes 10. So hence, what is the length of the chord LM? 10 centimeter, which is at a distance of 12 centimeter from the center. So pause the video to note it down. Alright, for question number 5, make the figure. This is the figure for question number 5. So in the given figure, AD is a straight line. In the given figure, AD is a straight line. OP is perpendicular with AD. OP is perpendicular with AD. O is the center of the circle. 3 things given out here. Okay, 3 things given out here. Please go step by step. 2 concentric circles are there. So this is the inner circle, this is the outer circle. By the way, concentric circles means circles having the same center. So this smaller circle as well as the bigger circle has the same center O. So these are the concentric circles. O is the center. AD is a straight line, and OP is perpendicular to AD. 3 things given out here. AO 34, which is the radius of the bigger circle. OB 20, which is the radius of the smaller circle, and OP is 16. Right? What we need to find is find the length of AB. I need to find the length of AB. This AB I need to find. How will I do? See, there are 2 right angle triangles. OPB, OPA. There are 2 right angle triangles, OPB, OPA. Using the smaller right angle triangle, OPB, I'll find the length of BP. And using the bigger right angle triangle, OPA, I'll find the length of AP. And therefore, if I subtract AP minus BP, I'll get the value for AB. So this is how we do. Let's see the solution. So therefore, as I said, there are 2 right angle triangles, OPA and OPB and OPA. So please write down OPA, OPB, this is the smaller right angle triangle, and OPA, this is the bigger right angle triangle. From this, what will I do is I'll find the length of BP and AP. So let's look at the calculation. The length of BP is 12, the length of AP is 30. Right? So from here to here it is 30, from here to here it is 12. So if I subtract, then I'll be getting the length of AP. Now from the figure, look at the calculation. AP equals to AB plus PB. AB plus PB. Put the values accordingly. 30 minus 12. So what is the length of AB? Is 18 centimeter. So I hope you're clear with this. So pause the video to note it down. Alright, in this way I move to question number 8. For question number 8, please make the figure. Let's make the figure first and then I'll explain you. Great, I hope you're done with the figure. Okay, so this is the figure. Out here, O is the center. AB is the diameter. I hope you can see. I told you diameter means a straight line passing through the center. AB is the diameter, and CD is one of the chord. Okay, what we can see out here is AB and CD they are intersecting at point P. Alright, so this is 90 degree, this is 90 degree, no doubt. Okay, the things given out here is OA equals to OB equals to 15. OA from here till here it is 15, and from here till here OB it is again 15. OP is 9, so OP from here to here it is 9. Okay, so from here to here 15, here to here 15, from here to here 9. So clearly you can see this to this will be 15 minus 9, which will be 6. So what is the length of PB? PB is 6. Please remember that PB is 6 out here. Okay, what are we asked to find? We are asked to find the length of CD. Find the length of CD. Find the length of CD. I need to find the length of CD. Now in order to find the length of CD, what should I do is I have to find PD or CP first. Once I get this or this value, then multiply into 2, you will get CD. So that's the reason we have to do construction. Join OD. So I have to join O and D. So I am joining O and D so that I get a right angle triangle. So in right angle triangle, in which right angle triangle I'm talking about? OPD. OPD. In this right angle triangle, we know OD square will be OP square plus PD square. Right? Hypotenuse square equals to perpendicular square B square. Now remember that OD is also your radius. OD, isn't it not? Because O, center, circumference, if I join any straight line from center to circumference, it is the radius, isn't it? And I know the value for radius. If this is 15, then this is also how much? 15. So now the calculation becomes very easy. 15 square is equals to 9 square plus PD square. So find the length of PD. How much? PD is 12. So PD is 12. So once I get PD is equals to 12, what will be the length of CD? No doubt it will be 24. 12 plus 12 will be 24. So number one, okay, question number 1, the length of CD is how much? 24. Now we move to question number 2. AD, find the length of AD. You can see A is up here and D is here. So construction, again join AD. The reason I am doing construction is, see, I have to get a right angle triangle. Join AD. So for this I am going to use my ruler. So I am going to join AD. So please join AD. Alright, this is my AD. So I hope again you are clear with the right angle triangle which I am talking about is APD. Right, APD. You can even make a figure out here. Right angle triangle, APD. Right, I need to find the length of AD. What is the length of PD? Just now we got 12. And what is the length of AP if I ask you? AP. Look in the figure again. AP. From here to here 15, from here to here 9. So what is 15 plus 9? 15 plus 9 will be how much? 24. And this is 90 degree. So now it's very easy. On this figure, use your Pythagoras theorem. So by Pythagoras theorem, AD is equals to root over 720 and square root of 720 will be 26.83. So this is your 8 part 2. Pause the video to note it down. Right. Now we move to third part. In the third part, you are asked to find the length of CB. The length of CB. Again, let's come back to the figure out here. CB. Where is my CB? CB is out here. CB. So I have to join C and B. Please join C and B. I have to find CB, right? So CB also you can see here is again here is a right angle triangle. See, by the way, this is your 9, and this is your 12, and this is your 6. So CPB is a right angle triangle. 12, 6. You know how to do. Just use a Pythagoras theorem. The solution is out here. The solution is out here. So in right angle triangle, CPB. See, it is somewhat like this, C, and this is B, and this is P. This was 90 degree, this was your 12, and this was your 6. So all the calculations are out here, right? So CB equals to how much? 13.42. Pause the video to note down. So now we move to the last question from this exercise, which is question number 9. Again, make the figure and let's read the question. So this is the figure given to us. In the given figure below, shows a circle with center O. It shows a circle with center O, okay, which is diameter. In which diameter AB bisects the chord CD at point E, right? Okay. All in all, there is a circle. AB is the diameter and CD is the chord, and they are bisecting at point E. Alright, okay. In which the diameter AB bisects the chord CD at point E. Okay, by the way, this diameter, okay, this diameter is bisecting this chord CD at point E, which means this is 8 and this is 8. As I've mentioned out here, this is your 8 and this is your 8. Okay, the question is also given to us the length of EB. EB is 4. From here to here it is 4. Find the radius of the circle. So I need to find the radius of the circle. Okay, since I don't know the radius, okay, before that, I hope you're clear with the figure, the diameter and the chord. So what you do is join OD. So join O and D, isn't it or not? OD in the figure. See, I have to get right angle triangle. Without right angle triangle, I will not be able to find the radius. Okay, so join OD and assume it as X. I have assumed this as X. So from here to here it is X. It is the radius. If from here to here it is X, then no doubt from here to here is also X, isn't it or not? From here to here it is also X. But this value is 4. So therefore this from here to here will be X minus 4. Okay, I hope you're clear. Great. So therefore now the right angle triangle out here is this OED. Also the calculation for OE is out here. Okay, see, OB equals to X. OB is equals to X, but I know OB is OE plus EB. OE plus EB. So value for EB will be X minus 4. Right, this is X minus 4. So in right angle triangle OED, use the Pythagoras theorem. X square is equals to this square plus this square, which is this. Now therefore X square expand with A minus B whole square. A square plus B square minus 2AB plus 64. See out here, X square and X square gets cancelled out. So therefore 8X is 64 plus 16. So therefore 8X equals to 80, X equals to 10 centimeters. So hence the radius of the circle is how much? 10 centimeter. So pause the video to note down. Right, that was the last question from this exercise, and the homeworks that we'll do is question number 3, question number 7 and question number 8. So thank you for today's class. So we'll see you with exercise 17B.